that's a very cool story that, again, it's very important because just genetics could define a new lineage, a new human lineage that today is extinct. I tend to avoid the word species, as you will see, because as long as part of their genetics is in us, that showed that we were not different species, because in theory, two different species doesn't give rise to offspring that is fertile. The fact that you and me, we have 2% of our genomes that are of Neanderthal ancestry, show that Neanderthals and modern humans, Homo sapiens, were not a different species. So I tend to say human lineages. So the Denisovan lineage is very interesting because just thanks to genetics, it was discovered. Everything started in a cave in Siberia that is called the Denisova cave, where they found a little piece of a finger. They thought that was on the basis of a little thing like that. They thought that was from a Neanderthal because there were other remains of Neanderthal in that cave. So the group of David Reich and Svante Pääbo, so Harvard, Leipzig in Germany, Harvard in Boston, they sequence that and they compare it, the sequence of that, the DNA extracted from that little finger from a Neanderthal sequence. And they say, oh, that's not a Neanderthal. If we compare the two sequences, we show that the two sequences diverge from each other around 500,000 years ago. So, thanks to genetics, because on the basis of just this, a little finger, you cannot say this is a Neanderthal or whatever. So, they discover a new lineage, a new human lineage that got extinct. And now, by comparing that genome of the Denisovan, the name was given because of the cave where it was discovered. We know that the East Asians populations, they have around 0.1% of their genomes, present day East Asians, that come from Denisovans, and present day people from near Oceania, Papua New Guinea, the Solomon Islands, the Vanuatu archipelago, can have up to 3% of their genomes that are of Denisovan ancestry.